One important thing you have to know before we start optimizing the scene are render slots. With render slots, you can easily compare different settings. For example, here I render this image with 10 samples. Then I click on render. Now it's finished, and here you can see this render is on slot 1. And now I can switch to slot 2 and change the samples to 100, for example. Then render it again. And now we can easily switch between the different render slots with the numbers on the keyboard. For example, for render slot 1, I press 1, and render slot 2, I press 2. And you could also change the render slot with J. Since you know how you can easily compare images, you can now experiment with the different amount of samples, and I would always recommend using the noise threshold. With the noise threshold, Blender automatically reduces the number of samples per pixel with the estimated noise level. And the higher the noise level is, the more noise will be at the end. So you have to play with it. For most cases, leave the min samples to 0 and then play with the max samples. If you are using cycles, then make sure that you have activated two things. First, go to Edit, Preferences and System, and make sure you have activated Optics if available, and also make sure that you only have activated the graphic card, because the problem is that the processor isn't very good in calculating ray tracing, so it only outbreaks the graphic card. If you have an AMD graphic card, then set it to HIP. And if you are having one of the new M1 or M2 MacBooks, then activate both, because it's a whole other architecture, and here it would be faster if you have activated the CPU and the GPU. And there you have to set it to metal. Always make sure that the device is set to GPU compute if you are having one, because otherwise it will render with the CPU, and this is very low. For example, if I set it to GPU compute, every frame counts, and be aware that most movies are made with 24 FPS. So I also set it to 24 in most cases. Blender isn't very good at calculating too small light points. I know it depends on the scene and sometimes you just need a small radius, but if you have larger scenes and it isn't so important if the radius is 0.1 meter or 1 meter, then I would suggest you to make the radius bigger. There's one important thing you have to know. The more lights you use, the noisier the image will be. I know it sounds funny, but it's true. It's due to the problem that Cycles has to calculate more light rays and that will need more samples. For example, we have the main light point with 100 watt, and we have the other light points and they just have 10 watt. And if I delete the other light points, the image is much clearer. You can find the different presets for the light paths under this icon. For example, we choose the limited global illumination, and now the reflective caustics are deactivated and the max bounces are reduced. You could also play with the clamping. To increase the render speed for volumes, you could either reduce the max steps, or you could increase the step rate for the render or viewport. For example, if I set it to 10, the cloud will be less detailed, but it will render much faster. And if I set it to something like only 0.1, the cloud is very detailed, but it renders very slow. Fast Gi Approximation is some kind of fake global illumination for cycles. So for example, if I activate it, you could see that the upper mouth is a bit darker, but overall it works pretty well and it can reduce the render speed pretty much. Especially for large scenes, the simplify option can be very useful. If you activate it, you could limit the max subdivisions or the child particles, the texture limit, or even the volume resolution, and this affects all objects. Now, after we have adjusted all parameters, we can finally go to the denoising, and you can find it under the sampling and under viewport and render. For example, we activate it for the viewport, and you could leave the denoiser to automatic, or I normally use optics for the viewport and OpenImage denoise for the final render. And the passes, I would recommend to set it to albedo and normal. If you make animations, then I would highly recommend to use persistent data. It's under performance and final render. If you activate it, the scene hasn't to be loaded every time again after each frame, but it will need some more RAM. To increase the render time, you can also make the motion bluer in the compositor. And for that, you first have to deactivate the normal motion bluer and then go to the view layer properties and make sure that the Z and the vector path is activated. After we have rendered the image, you can just put a vector blur node in between and connect depth to Z and the vector to speed. Blender has its own chapter in the manual for command line rendering, so you can easily render your scenes with the prompts that are listed here. You only have to adjust them, copy it, and paste it in a command prompt. If you want to render the same scene on several computers at the same time, then you just have to go to the output and deactivate the override function and activate the placeholders function. And now Blender looks automatically if the other PC have already rendered the image or if it's in progress. First, we make a new text document with right-click, new, and text document. We name it test, for example. We go in and then we write all render commands we want in a row and save it. And then we go to Anzeigen or display settings, probably in English. Then to the last row and we activate the file extensions. And then we click 2 times. And here we type in bad instead of txt and yes. And now it's a batch script.